Okay, this is the Trig unit number 2 review, questions 20 through 22. Establish the identity. So number 20 says we have sine x times tangent x cosine x minus cotangent x times cosine x, end of parentheses, equals 1 minus 2 cosine squared x. I'm going to start on the left-hand side because this side looks a bit more complicated. So what I'm going to do is I'm going to go ahead and write things out in terms of sines and cosines. So we have sine x here. Tangent is sine x over cosine x, and that's times cosine x, minus cotangent, which is cosine x over sine x, times cosine x. And then I'm going to simplify this down. So the cosines go away, and I'm left with sine x minus cosine squared x over sine x. So this looks a little better. And remember, this is still being multiplied by sine x. So now what I'm going to do is distribute. So I'm going to distribute sine x to sine x, which we get sine squared x. And then I'm going to distribute sine x to negative cosine squared x. When I do that, I get negative sine x times cosine squared x over sine x. And if you notice, these two sine x's will cancel each other. So now I have sine squared x minus cosine squared x. Remember, the result is I'm trying to get to 1 minus cosine squared x. So what I'm going to do is I'm going to use substitution. And I knew through Pythagorean theorem that sine squared x equals 1 minus cosine squared x. So once again, that was Pythagorean. The Pythagorean identity, and that identity is sine squared x plus cosine squared x equals 1. So once again, I just rearranged it so that I have 1 minus cosine squared x. Okay, so now that I did that substitution in there, I have this situation where I have 1 minus cosine squared x minus cosine squared x. This becomes 1 minus 2 cosine squared x. My left-hand side looks like my right-hand side, so I know that my identity is done. Please note, do not work on both sides of the equation. So once you establish what side you're working on, in my instance it was the left-hand side, I stay on the left-hand side. Alright, so let's look at number 21. Number 21 says I have cosine u over 1 plus tangent u minus sine u over 1 plus cotangent u, and that equals cosine u minus sine u. Okay, since this left-hand side looks so much more complicated, I'm going to work on that side. So what you're going to do, or what I did, was I rewrote everything in terms of sines and cosines. So tangent becomes sine u over cosine u. So right now I have cosine u over 1 plus sine u over cosine u minus. Now I'm going to rewrite the second one in terms of sines and cosines. So it's sine u over 1 plus cosine u over sine u. Okay, at this point I'm going to work on each one individually. I'm going to find a common denominator in the denominator, and then I'm going to simplify. So on this left-hand side, I get cosine u over cosine u over cosine u plus sine u over cosine u. And this becomes cosine u over cosine u plus sine u all over cosine u. Okay? When we simplify this, this becomes cosine u over 1 times cosine u over cosine u plus sine u. Okay, and I'm going to leave it at that for now because I'm going to work on the other one. So minus, minus, minus. So I'm going to put a little square around that. Okay, on this other side, I get sine u over sine u plus cosine u over sine u. Okay, so I get sine u, and we get sine u plus cosine u all over sine u. And then we do the same thing that we did to the other one. I'm going to put sine u over 1 times sine u over sine u plus cosine u. Okay, at this point, I want to make this look a little bit better. So I'm going to bring all this information up here and continue working. Cosine u times cosine u is cosine squared u over, and I'm going to put sine u first. The reason I can do this is addition is commutative, meaning I can change the order without really affecting the result. So minus sine u times sine u is sine squared u over sine u plus cosine u. Okay, now my next step is to combine like terms, or combine this together. So cosine squared u minus sine squared u over sine u plus cosine u. And believe me, I almost have it because in the numerator is the difference of perfect squares. So I can factor this out to cosine u plus sine u times cosine u minus sine u. And this is all over sine u plus cosine u. Okay, remember I can strike out binomials if they are exactly the same. So cosine u plus sine u and sine u plus cosine u are both the same. So my answer is cosine u minus sine u, which is my right-hand side. So it took a while to get there, but that is the answer. Okay, hopefully you understood that one, because I think that one's a little bit tricky. All right. Okay, I don't know why this is off center, but it is, so I'm just going to go with it. We're on number 22. So number 22 reads establish identity, and we have 1 minus cotangent squared, and I'm going to use an x here because I don't like those v's, over 1 plus cotangent squared x plus 1 equals 2 sine squared x. So once again, I look at this and my left-hand side looks so much more complicated than my right-hand side. Okay, so what I want to do is turn that 1 so it has a common denominator. So I'm going to put 1 minus cotangent squared x over 1 plus cotangent squared x plus 1 plus cotangent squared x over 1 plus cotangent squared x. Okay, now I'm going to have 1 minus cotangent squared x plus 1 plus cotangent squared x all over 1 plus cotangent squared x. Okay, so the cotangents will cancel each other, and I get 2 over 1 plus cotangent squared x. And if you remember from the Pythagorean theorem that 1 plus cotangent squared x equals cosecant squared x. And once again, this is one of the Pythagorean identities. So I'm going to substitute in 2 over cosecant squared x. And now I'm going to substitute in for cosecant. Cosecant can also be written in terms of sine. So if I rewrite this as 2 over 1 over sine squared x, this becomes 2 over 1 times sine squared x over 1, which equals 2 sine squared x, which is my right-hand side. So there I established that identity. Okay, thanks for listening. That was questions number 20 through 22, establish the identity.